So this lesson is going to talk about the conjugate root theorem. In the last lesson, we talked about the rational roots theorem, which we talked about how we could get all possible rational roots. Well, the conjugate root theorem deals with non-rational roots, so they could be irrational or imaginary. So what this theorem says is that if you have an imaginary root, such as 1 plus 3i, we can automatically know that its conjugate is also going to be a root. So 1 plus 3i has its conjugate of 1 minus 3i. So 1 plus 3i and 1 minus 3i would be roots. So if one is a root, so is the other one. Same thing with irrational roots. Irrational roots are numbers that are square roots or numbers that don't terminate or repeat. So non-perfect squares are irrational numbers. So if 4 minus square root of 7 is a root, so is 4 plus the square root of 7, which is the conjugate of 4 minus the square root of 7. So here's two more examples. If you want to pause, you can pause and try to fill in these answers. The answers are going to be negative 2 plus 9i, and then 15 minus the square root of 10. So if we move on, we can do example 3 here. So example 3 is going to ask us to write a third degree polynomial function with rational coefficients so that p of x is equal to 0 has the given roots. So if we know we have one of our zeros is x equals 1, another one of our zeros is x is equal to 2 minus 3i, and then since we have 2 minus 3i and it's imaginary, we know we have one more root, which is the conjugate, which is x is equal to 2 plus 3i. So if those are the roots, we need to create factors so that we can have a polynomial. So we can write p of x is equal to, so we remember we want to make our roots back equal to 0, so we're going to subtract that root over, and one of our factors is going to be x minus 1. Then we can do the same thing over here. We can do x minus 2 plus 3i. So x minus 2 plus 3i. And then the other one will be x minus 2 minus 3i. So x minus 2 minus 3i. And then we can multiply all this out to get this in standard form. So to multiply this out, I'm going to set up a 3 by 3 box for these two these two expressions to be multiplied together. I'm going to do that over here where I have some room. So I have x minus 2 and then plus 3i. I have x minus 2 minus 3i. So x times x is x squared. Negative 2x goes here. Negative 2 times x. 3i times x is 3ix. We have negative 2x here. Positive 4. And negative 6x. Here we have negative 3xi. We have positive 6i. And then we have negative 9i squared. I'm sorry, I made a mistake here. Let me correct that. This is not 6x. This is actually 6i, negative 6i. As you can see, our imaginary numbers are all going to go away because these are opposites. So right here and here go away. These are opposites here. And if you remember, I squared is a real number. I squared is negative 1, so we can do negative 9 times negative 1, which is positive 9. So right now I have the polynomial x minus 1 times, I'm going to combine my like terms here, x squared, and then negative 4x, and then plus 4. I'm sorry, plus 4 and 9, which is plus 13. So I added up all the areas of these parts of the square, and now I can multiply the x minus 1 through that, x squared minus 4x plus 13. So to do that, I'm going to draw another box here. So this time I have my x squared minus 4x and plus 13. And then over here I have my x, my negative 1. So x cubed minus 4x squared plus 13x, and then a negative x squared, and then we have a positive 4x and a negative 13. So in standard form, I have x to the third, and then negative 5x squared, and then 13 plus 4 is 17x, and then minus 13 is our constant. So that is how you can write a polynomial in standard form.